Today, we're going to try and answer a question that has haunted businesses for decades. It's a 60-year-old problem that honestly feels more relevant now than ever. And that question is, why is it still so ridiculously hard to get good answers from our data? See, this isn't just some tech problem. It's a story of constant change, where every brilliant solution seems to just create an even bigger, messier problem down the road. I mean, really, think about it. We have cloud computing that's practically infinite. We've got machine learning. We've got AI that can write poetry. And yet, so many organizations are still struggling to get simple, trustworthy answers from their own information. You'd think this would be a solved problem by now, right? Well, the really surprising thing is that this isn't a new frustration at all. It's just the latest chapter in a saga that's been going on since the dawn of computing. And to really understand where we are today, and more importantly, where we're going, we have to go back, way back, to the beginning. And here's our roadmap for this journey. We're going to start in the 60s with the birth of the very first databases. Then we'll see how math brought order to the chaos with the relational model. After that, we hit the Great Divide, the super curated world of the data warehouse versus the wild west of the data lake. And finally, we'll land right here, in the present day, with the attempt to bring it all back together with the Lakehouse and the new challenge of AI. So, let's dive in. Our story kicks off in the 1960s, and it doesn't start with fancy analytics or big data. Nope. It starts with a much, much simpler problem. Absolute, total application chaos. You see, back then, every single application had its own little private silo of data, completely locked away. It was a mess. So the very first databases had this incredibly simple yet totally revolutionary goal: create one central system that could actually answer questions. A system that could keep data consistent and, let more than one person use it at the same time without the whole thing crashing down. They were chasing this core idea of queryability, just the basic ability to ask your data a question and get an answer you could count on. Now, that first step was huge, for sure, but it was still a bit loosey-goosey. The next great leap forward was all about bringing some serious mathematical rigor into the picture, building a system that you could truly trust. And that brings us to the relational database. This was all sparked by a groundbreaking paper in 1970 by Edgar Codd, and his idea was radical. He said, instead of all these messy, complicated data structures, what if we just organized everything into simple tables governed by strict mathematical rules? And just like that, for the very first time, you could actually have mathematical proof that the data in your systems was trustworthy. So why did this one idea completely take over the entire business world for decades? Well, it came down to 3 huge wins. First, it just wiped out tons of errors and inconsistencies. Second, it gave us SQL, a universal language that both the tech folks and the business folks could understand. And third, and this is the big one, it gave us something called ACID transactions. Think of ACID as a sacred promise, a contract with your data that guarantees it will never get corrupted. Even if the power goes out mid-sale, your data is safe. This was and still is the bedrock of running a business on software. But, and there's always a but, isn't there? The relational model was so good at its job at running the day-to-day business, processing thousands of tiny, rapid-fire transactions, that it completely choked on a totally different kind of work, asking big, deep, analytical questions about the business. And that fundamental conflict, that tension, is what created the need for the next big thing in our story. This brings us into the modern analytics era, an era defined by this absolute flood of new data and a major split in philosophy. A real fork in the road. Should we carefully curate our data, or should we just store it all raw and unfiltered? On one side of that fork, you had the data warehouse. And it is so important to understand that a warehouse isn't just software. It's a discipline. It's the slow, careful, painstaking process of taking all the messy, conflicting data from every corner of the business, cleaning it up, and modeling it into a single, pristine source of truth. And the value for the business was just incredible. For the first time, a CEO could ask a really complex question like, what was our total profit by product line in the European market for Q3? And get one single, consistent answer. Finally, the word revenue meant the same thing to the sales team and the finance team. These systems were fast, they were secure, and they were built from the ground up for this kind of deep, serious analysis. But man, it came with some serious baggage. Building a warehouse was painfully slow, The rigid structure just couldn't keep up with the explosion of new, messy data coming from websites and mobile apps. And the cost? The cost could be absolutely eye-watering. The growing frustration with these limits is what paved the way for a totally radical opposite approach. And that brings us to the data lake. This whole idea was powered by the arrival of super cheap cloud storage. And the philosophy was the complete opposite of the warehouse. The new mantra was basically just store everything, dump it all in its rawest, messiest form. We'll figure out what to do with it later. And this slide just lays out that philosophical war perfectly. The warehouse is like a meticulously organized library. You have to figure out the structure, the schema, before you put any books on the shelves. We call that schema on write. The lake? That's more like a giant messy garage. You just throw everything in there, raw, unstructured, and you only try to make sense of it or define the schema when you go looking for something. We call that schema on read. One is all about control, the other is all about flexibility. But pretty quickly, people started to see the fatal flaw in this store everything approach. The folks at Gartner even gave it a name. They called it the data lake fallacy, this obsession with storing data while totally ignoring the hard work of governing it, securing it, and, actually using it. And so, in what's becoming a familiar pattern in our story, the solution created a brand new problem. The beautiful, promising data lake all too often decayed into the dreaded data swamp, a murky, unusable, and completely untrustworthy mess of forgotten data. This failure, this swamp, really set the stage for the architecture that dominates the conversation today. A modern attempt to finally unify these two opposing worlds and, hopefully, get the best of both. And that is the Lakehouse. The core promise is actually simple, but it's incredibly powerful. The idea is to take all the awesome flexibility and low cost of a data lake that's built on open formats, but then layer the reliability, the performance, and the governance features of a traditional data warehouse right on top of it. So how does it actually work? Well, you can think of it like a recipe. You start with cheap, basic cloud storage. Then you add a really clever metadata layer on top, technologies like Delta Lake or Apache Iceberg, that magically make all those raw files start behaving like real, reliable database tables. Then you layer on a governance catalog for security and tracking, and here's the magic part. You can then point all your different tools, your SQL engines, your machine learning models, anything at that same single copy of the data. And of course, the evolution doesn't stop there, because now that we have this unified platform that can handle both clean, structured data and messy, unstructured data, we're actually ready for the next great frontier, AI. These modern architectures are now being tweaked and adapted to handle the totally new kinds of data that power AI, like the vectors and embeddings that large language models run on. Okay, so we just went on a whirlwind tour of 60 years of data history. But what does all of this actually mean for you today, trying to get work done? Let's pivot and get to the practical, no-nonsense takeaways. This is the consultant's bottom line. If you remember one single thing from our time together, please let it be this. A disciplined team working on a boring old data warehouse will always outperform a team that's just chasing the latest, trendiest Lakehouse tech without a rock-solid plan for governance. The technology is just a tool. At the end of the day, success or failure almost always comes down to people, process, and discipline. So instead of chasing buzzwords, the key is to pick the right architecture for the job you're actually trying to do. If your world is all about rock-solid dashboards, strict KPIs, and business intelligence, you should be thinking in terms of warehouse semantics. If you're exploring brand new data sources, mixing formats, and training machine learning models, then yeah, the Lakehouse pattern is probably a fantastic fit. And if you're building the next generation of AI-powered search or recommendation engines, you're going to need multi-modal capabilities. Fit over fashion. And this maturity ladder right here is maybe the best way to summarize our entire 60-year story. We started by just wanting basic queryability, the ability to ask a question. Then we demanded reliability, so we could trust the answer. That led to decisionability, where leadership could actually run the business on that data. We chased optionality with the data lake, which led us to the current era of unification with the Lakehouse, finally bringing everything together. And the next, final rung on the ladder, becoming truly AI native. So I'll just leave you with this one critical question. The next time you're thinking about adding that shiny new tool to your data stack, just stop and ask yourself, are we actually modernizing our capabilities and making things simpler? Or are we just multiplying our chances to fail? The answer to that question will make all the difference.